Good afternoon, dear students. So, in the previous class, right? So, we have discussed the about inner transition elements. So, what are inner transition element? That is the F block elements. So, accordingly, we have studied about lanthanides. Okay, their general electronic configuration, physical properties, chemical properties. Okay, so important everything we have discussed about the inner transition elements, that is your lanthanides. Then we had also discussed about the actinides. What are actinides? Okay, which are the elements which can come under actinide series, right? And what are the different properties of actinides, that is their physical properties and the chemical properties, right? So today we are going to discuss some of the important applications about lanthanides and actinides. So before that, let us see first the differences. Okay, first let us see the differences between lanthanides and actinoids. Okay, now what are the difference between the lanthanides and actinoids? So when we see about lanthanides, okay, so lanthanides, these are the chemical elements which are found in the periodic tables F block of the lanthanide series. Okay, so these are found in what? It is found in the F block, but in the lanthanide series. And from where the atomic number it ranges from? It ranges from 57 to 71. Okay, so the elements which come under this range, they are put into the series of lanthanides. Okay, then here in actinoids, okay, what are actinoids? So actinoids are the chemical elements, okay, which are found in the actinide series of the F block in the periodic table. Okay, and so the atomic number, it comes between 89 to 103. So these are the elements. Okay, these are the atomic number of the elements which come under actinoid series. So F block, it consists of togetherly lanthanide series and actinoid series. So lanthanide, it starts from 57 to 71, and actinoids, it ranges from 89 to 103. Okay, then we'll go for the second difference. So they are from the sixth period. Okay, so lanthanides, they are from the sixth period and it belongs to the third transition series. Okay, and they make up the first inner transition series. So they belong to what? They belong to sixth period. Okay, and they belong to the third transition series, and these are the first inner transition series. Then when we come to actinoids, so they are from seventh period. Okay, they belong to seventh period and they belong to the fourth transition series. So where they belong? They belong to the fourth transition series. Okay, which is the second inner transition element. So first are your lanthanides, then is your actinoids, which are your second inner transition series. So this is the second difference. So lanthanides, they are in sixth period and actinoids, they are in your seventh period. Okay, then lanthanides, okay, the valence electrons are present in the 4f orbital. So in lanthanides, the valence electron, where they accommodate when you put the electronic configuration, okay, the last electrons, they will be present in the 4f orbital. And in actinoids, the last electron, valence electrons are nothing but the last electrons. Okay, so the outermost electron. So these outermost electron, they will occupy into the 5f orbital. So when they occupy into the 5f orbital, they are termed in the actinoid series. Okay, they are termed in the actinoid series, and they when they are put into the 4f orbital, then they are termed under lanthanoids. Okay, so lanthanoids and actinoids. So very important. Okay, next is the binding energy. When we are discussing about the binding energy, so the binding energy of 4f orbital is greater. Okay, so when we are discussing about the binding energy of 4f orbital is greater and that of the actinoids is lesser. So for 5f orbital is lesser. So binding energy of the 5f orbital is lesser. Okay, so these are the differences. Next, though only a few cases, besides the +3 oxidation state, Lanthanides also show +2 and +4 oxidation state. So as we have seen this, so lanthanides most commonly they occur in +3 oxidation state. Apart from this, they also show +2 and +4 oxidation state. Okay, so this is about your oxidation state. So lanthanide most commonly they occur in +3 and and they also show what +2 and +4 oxidation state. Then actinoids, when we talk about actinoids, okay, so actinoids they are having some higher oxidation state. Okay, besides +3 they will show +4, +5, +6 and +7. So these that is your actinoids, they show a quite higher oxidation state as compared to that of your lanthanides. Okay, then next is they are ions. Okay, so in lanthanoid most of their ions are what they are uh, in lanthanoids. Okay, in lanthanides most of the ions are what they are colorless. Okay, they are colorless. So they are what they are colorless. Okay, and the actinoids, in actinoids, okay, they are colored. So most of the ions are what they are colored in actinoids. Okay, so these are the main differences, these are the main differences, okay, about the lanthanoids and actinoids. So what you can see here, you can see that so lanthanoids most commonly what is seen that lanthanoids, okay, the ions are colorless. Okay, and actinoids they are mostly colored. So remember this. Then lanthanoids, their tendency to form complex ions is less. So in lanthanoids the formation of complex ions, okay, it is bit less as compared to that of actinoids. Actinoids has the greater tendency to form complexes. Okay, they have a greater tendency to form complexes. Okay, then their compounds are less basic than actinoids. So lanthanoids, okay, the compounds they are less basic as compared to actinoids, and in actinoids they are more basic than the lanthanoids. Then lanthanoids they are non-radioactive. Okay, they are non-radioactive except for promethium, and actinoids all the other elements, okay, all the other elements in the actinides all are radioactive. So in lanthanides only promethium is radioactive, while rest of all the metals are what they are this what non-radioactive. Okay, so these are the main differences between lanthanoids and actinoids. So you need to know, so what are the main differences here? Okay, fine. Let's go for the next one. So, so any doubts in the application? This your differences. Okay, so we have seen. Okay, we have seen separately. Here, what we have done, we have combined it in the form of differences. Okay, we have combined it in the form of differences. Okay, so that it will be more quick for you to recap everything. Okay, let us go for the next one, that is application of D and F block elements. Okay, next is the application of D and F block elements. Iron and its amalgam. Okay, iron and its amalgam steel are utilized broadly in the development industry. So iron, that is iron and its amalgam. Okay, that is amalgam is nothing but sodium amalgam is what NaHg. So when your amalgam, that is your iron and its amalgam, that is steel. So these are where we use them in the industries. Okay, in the development of industries. Then titanium. Okay, next is titanium. So titanium, it is as a part of manufacture of airship and spaceship. So we use titanium. So titanium, where we use it in the parts. Okay, for manufacturing of airship and spaceship. Then tungsten. So tungsten, it comes in So tungsten, it comes in use of making electrical fibers. Okay, where we are using tungsten, we are using tungsten in making of electrical fibers. So then manganese dioxide, it comes in use as a part of dry battery cells. So manganese dioxide, where we are making use of, we are making use in the part of dry battery cells. Okay, we are making use in the battery cells. Then zinc. So zinc, where it comes in use as a negative anode in the fixed dry battery. So in the dry battery, it is used as a negative anode. Okay. So negative anode in the dry batteries. Then niobium. Okay, niobium, where niobium composites are perfect as a part of fly motors. So niobium is also element, okay, whose composites are perfect as a part of fly motor. So these are some of the application where we are using it into our day-to-day life. Okay. Then tantalum comes into use to make expository weights. Okay. So silver bromide, it comes into use as a part of photography. So in the photography purposes, we make use of silver bromide. Okay. Earlier, black and white photos. Okay. So when so the dark when you want to do the this what when you want to remove the color prints, okay, of the photos. So you take those photographic films under a dark room, okay, and then you expose it to silver bromide, okay, so that whatever the pictures are there, so they get what highlighted on that paper, okay. So silver bromide is the main in use for the part of photography. Then many D block or transition metals and their compound find their use as impurities in the chemical reaction. So most of the D block and the transition elements, that is D block or transition elements and their compounds, we are making use, okay, in the chemical reactions. Then palladium chloride, okay, palladium chloride, it comes into use in the Walker process of oxidation of ethane to ethanol. So in preparation of ethanol, that is when you do oxidation on of hydrocarbons to alcohol, okay, we are making use of palladium chloride. So which is a process name? It is a Wacker process, okay. Then iron. So where we are making use of iron in the production or in the manufacture of ammonia in Haber's process. So Haber's process is a very important process in which we are making use of iron as a catalyst, okay, that is ferric oxide, okay. So that is used. Then next, very important, Ziegler-Natta. So remember what is Ziegler-Natta? What is the name? So it is a catalyst. Ziegler-Natta, it is a catalyst. Okay. So what is it is made up of? It is made up of trimethyl aluminium. What is Ziegler-Natta complex made up of? It is made up of trimethyl aluminium and titanium tetrachloride come into use in the polymerization of ethene to polythene. Okay, so these are the uses. So Ziegler-Natta, very important, mark this as important. Okay, not here also, in organic chemistry also, Ziegler-Natta. What is the composition of Ziegler-Natta? If it is asked, okay, for CET point of view, okay, or in the MCQs or fill in the blanks, okay. So what is Ziegler-Natta? It is a complex which is made up of trimethyl aluminium and titanium tetrachloride, okay. So it is used in polymerization of ethene to polythene, that is in the production of polythene, okay, polythene bags. So in that we are making use of polymerization. We are taking simple molecule like ethene and we are converting it into polythene. We are making use of the Ziegler-Natta catalyst. Okay, so these were some of the this application of D and F block elements. Okay, let us go further. So next, uses of F block elements. So we'll see some of the uses of F block elements also. So lanthanides, lanthanides alloys. Okay, that is the mixed metal. So we have studied about mixed metals also. So it is utilized for the creation of instrumental steels and heat resistance. Okay, So lanthanide alloys mish metals. So where these mish metals are utilized, it is utilized for the creation of instrumental steels and heat resistance. Okay. So we are making use in the steels and heat resistance. So there we are making use of this alloys. That is a lanthanide alloy, which is called as a mish metal. Then carbides, borides, and nitrides of lanthanides. So we have seen how we get carbides, borides, and nitrides. Okay, so lanthanides, when it reacts with nitrogen, you get lanthanide nitrate. Okay, when it reacts with boron, you get respective borides, and with carbon, you get carbides. So these come in use as a refractories. Okay, refractories means what? So they will be big furnaces. Okay, big furnaces means okay, big like how you bake your bread, okay, under the big surfaces. Okay, it will be having a very high temperature. Now for making of bangles also, okay, what they do, there will be a big furnace in where the glass is been put there and it is converted into a slurry, liquid slurry. Okay, then the bangles are made like that. So refractories means big this chamber like thing, okay, where the temperature will be very extremely high. Okay, so these are lanthanides of okay, so respective carbide, borides, and nitride come in use as refractories. Then lanthanide oxides come in use in cleaning glass as abrasive. Okay, so lanthanide oxides, where it comes in use, it comes in use in cleaning glass. Okay, for cleaning the glasses, it comes into picture. Okay, so these were some of the uses of your the F block element. Is it clear? Yes. Any doubts up to here? So in today's class, we have seen the application as well as the we have seen the application of D block and F block element. Yes. So any doubts up to here? Yes. So in the last class, I had asked you two questions. Okay. So, and I told you that I'll be giving you important questions on this so that it will be easy for you while studying. Right. Okay. Any doubts up to here? First, let me ask you. Any doubts up to here? Yes. Okay. Pavitra has no doubts. Others? Okay, fine. So I'll tell you some of the. So this completes your chapter DN F block element. Okay. So what we will do. So I'll tell you the important questions. Okay. I'll tell you the important questions from this chapter. So from this chapter, okay, you will get what you will get is you will get this particular chapter. Just a second. So this particular chapter is for 11 marks. Okay, 11 marks. So from this 3 marks question, you will get 3. So 3 marks, 3 questions, and 1 mark, 2 questions. So 3 plus 3 into 3, 9, and 10, 11. So 1 mark, 2 questions, and 3 marks, 3 questions. Okay. So most probably 1 question, 1 mark, 1 question will be 1 mark, 2 questions. Both will be the MCQs question. Okay. You will get MCQ 1 mark, 2 questions, and 3 marks, 3 questions will be in the form of your this give reason, okay, or the preparation. One question is fixed on the preparations. Okay, then what are the important questions? So I'll be asking you questions. Okay, so let us solve together so that you will get idea also. Okay. Hmm. Yes, I had asked you last time. Transition elements show variable oxidation state. Transition elements show variable oxidation state. What is the reason why it show variable oxidation state? Yes. What is the reason why transition elements show variable oxidation state? So this is a question for 2 marks. 2 marks question. So the question can be asked directly for 3 marks, that is for preparation, or it can be 2+1. Okay, so 3 marks question directly it can be asked, or 2+1. So one can be a like this, give reason. So transition elements, they show variable oxidation state. That is because the energy difference, okay, energy difference between n-1d and ns orbitals is less. Okay, so the energy difference between n-1d and ns orbital is less. Therefore, all these electrons can involve in bonding. Involve in bonding. So because of this reason, so because the energy gap, okay, because the energy gap between the n-1d and your ns orbital is very less. So because of that, all the electrons can involve in bonding. So this is the reason. Okay. Let us go for the next one. So calculate. So calculate the magnetic moment of. So this at least you can tell me. Magnetic moment, very important question. Ask for again 2 marks. 2 marks each. Okay. So one, so I'll give you, so Mn plus 2. The atomic number is given 25. So each question here is for 2 marks. Okay. So second one, Fe plus 2, 26. Then third one, chromium plus 3, atomic number 26. Then 24. Okay. Then titanium plus 3, 22. Yes. Find out. You know the formula. What is the formula? Yes. Mu is equals to root of n into n plus 2. Yes. Do it. Solve. Yes. Okay. Please tell me the answers. For first one, what will be the answer for first one? Mn plus 2. So Mn plus 2 is what? Mn is 25. So argon 3d5 4s2. Right? 18, 19, 20, 25. So Mn plus 2 is 3d5. So number of unpaired electrons is how many? So 1, 2, 3, 4, and 5. So put the value n is equals to 5. So it will be mu is equals to 5 into 5 plus 2 is equals to 5 into 7. It will be square root of 35. So square root of 35 is how much? Square root of 35 is 5.916 Bohr magneton. Okay, Bohr magneton. Yes. Are you solving? Tell me the answers. Okay, you can do the next one. Fe plus 2. Fe plus 2. Yes, Fe plus 2. Fe plus 2. Fe is 26. So argon 3D 3d6 4s2. So Fe plus 2 is 3d6. So write 1, 2, 3, 4. So 1, 2, 3, 4, 5, and 6. Unpaired electrons are 4. So mu is equals to square root of n into n plus 2. 4 into 4 plus 2 is equals to 4. 4 plus 2 is 6. Square root of 24. How much it is? Just see what answer you're getting. Yes, you should get 4.90 Bohr magnetum. Are you getting? Yes. So next is chromium. Chromium is 24. So it is 3D argon 18. 3d5 4s1. So our chromium is plus 3. So it will be 3d3 6. Yes. So number of unpaired electrons is 3. So 1, 2, and 3. So mu is equals to 3, 3 plus 2, 3, 5. Square root of 15. How much you're getting? You should get it as 3.87 Bohr magneton. Are you getting the same? Yes. Please answer. Next is titanium. Titanium is 22. Argon 18. 3d2 4s2. Titanium is plus 3. So it will be argon 3d1. So 1 unpaired electron. So mu is equals to 1, 1 plus 2. 1 into 3 into 3. So square root of 3 is, yes, square root of 3. It will be 1.73 Bohr magnetum. Okay, like this. So each question for 2 marks. So this will be asked. So any one ion will be given and you have to calculate the magnetic moment. Is it clear? Yes? Okay. Let us go for the next one. Why scandium plus 3 and titanium plus 4 salts are colorless, whereas chromium plus 3 salts are colored. Yes, give me the reason. This is a 2-mark question. 2-mark question. Why scandium plus 3 and titanium plus 4 salts are colorless, whereas Cr plus 3 salts are colored? What is the reason? What is the reason why the ions are colorless and colored? Yes. What is the reason for the colorless and colored ions? Why scandium plus 3 and titanium plus 4 are colorless, whereas the chromium plus 3 salts are colored? What is the reason? Please answer. I'll take titanium. When titanium is 22, so argon 18. Okay, 3d2 and 4s2. So titanium, when it undergoes plus 4, so it will be how much? It will be 0. It will be 3d0, 4s0. Right. So whenever you have D0 or D10 system, either completely what? So here there are 0 electrons. Okay, or it should be completely filled. So then it will be colorless. Then it will be colorless. However, when chromium plus 3 means it is chromium is 24, so it will be 3D 5 and 4s1 argon. Okay, so chromium plus 3 means it will be 3D 3. So you can see that there are 3 unpaired electrons. How many unpaired electrons? 3 unpaired electrons. So because of the presence of unpaired electrons, okay, they will be colored. The complexes is colored. So scandium plus 3 or titanium plus 4 does not contain any d electrons, whereas chromium plus 3, okay, it contains a 3 unpaired electron. Because of this, these are colored in nature. Okay. Next one. Next question. Copper plus 2 ions are colored. Copper plus 2 ions are colored, but Zn plus 2 ions are colorless. Give reason. Yes, students, give reason. Again, 2 marks question. Why copper plus 2? Copper is 29. So it is argon 3D10 4s1 29 and zinc 30 argon 18 3D10 4s2. So copper plus 2 means it will be argon 18 and 3D9, and zinc plus 2 means argon 18 3D10. So what you can see that here, when you write the electronic configuration for copper, what you can see that there are how many unpaired electrons? Yes, students. Here there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is a 1 unpaired electron, and here it is 3D10, right? So all are paired. All are paired. One unpaired electron is present. So because of this one unpaired electron, these ions are colored, and all are here paired electrons. So these are colorless. So remember that whenever you have D0 or D10 system, they are colorless in nature. Okay, fine. Go for the next one. Transition metals and their compounds are used as catalyst. Transition metals and their compounds are used as catalyst. What is the reason? Give two reason why the transition elements and the transition elements and their transition metals and their compounds, why they are used as catalyst. What is the reason? So the reasons are, okay, the reasons are due to variable oxidation state. Second one, presence of vacant d orbital, vacant d orbitals. Then formation of intermediate products, intermediate compounds, formation of intermediate compounds. Then it provides large surface area, provides large surface area for adsorption of reactant molecules. Okay, so these are the, so any 2 points you can write. So again, this question is asked for 2 marks. Next question. Next question. What are interstitial compound? Write any one of their characteristics. Okay. So what are interstitial compounds? So interstitial compounds, they are formed when small atoms like hydrogen, carbon, nitrogen, they are trapped inside the crystal lattice of metals. Right. So characteristic, they are having high melting point, they are very hard. Okay, they contain metallic conductivity and they are chemically inert. Okay, so these are some of the important points. Okay, next, very important. So these are some of the 2 marks question. So let us go for the 3 marks question now. So 3 marks, very important question is preparation of dichromate. Okay, so very important is preparation of dichromate. Process of preparation of potassium dichromate. Potassium dichromate. So the 3 steps, that is from chromite ore. From chromite ore. Very important. Very important. Okay. 3 marks question. Compulsory question for 3 marks. Then preparation of potassium permanganate. So preparation of potassium permanganate. Okay, from MnO2. So this is also a compulsory 3 marks question. Okay, so very important. So any one of the question is compulsory. So any one is asked only. Then we'll see the F block elements question. Okay, F block elements question. What is lanthanide contraction? What is the cause for it? What is lanthanide contraction? What is the cause for it? Okay, so the steady decrease in the atomic and ionic size along the lanthanide series with the increase in atomic number, okay, is called as what? Is called as the lanthanide contraction. Okay, and what is the cause for it? Because of imperfect shielding of 4f electrons. Because of imperfect shielding of one electron by another in the 4f subshell. So this is about the first question. Then second question is what? Mention any 2 consequences of lanthanide contraction. What are the 2 consequences? One is similarity in atomic size of elements of second and third transition series. Then the separation of lanthanides in the pure state becomes very difficult. Okay, so these are the important questions. Next is what is actinide contraction? Okay, and why actinide contraction is greater from the element to element than lanthanide contraction. So the reason is it is a steady decrease in the atomic and ionic size along the actinide series with the increase in atomic number. So why the actinide contraction is greater than that of lanthanide contraction? Because it is due to poor shielding of 5f orbitals, okay, or 5f electrons. So it is due to what? It is due to the poor shielding of 5f electrons. Okay. So this is the reason. So these are the 2 marks questions. So first is what is lanthanide contraction? Explain the cause for it. Mention it 2 consequences of lanthanide contraction. What is actinide contraction? And actinide contraction is greater than that of lanthanide. So these are the 3 questions for 2 marks each. Next is atomic zirconium and hafnium have almost same size radii. What is the reason why hafnium and zirconium are having same atomic radii? What is the reason? It is due to why hafnium, very important 2 marks question. What is the reason? It is due to lanthanide contraction. Okay, due to lanthanide contraction, hafnium and zirconium are having similar radii. Got it? Actinides show variable oxidation state. Why actinides show variable oxidation state? What is the reason? Because the energy gap between the 5F60 and 7S is almost same. So the energy gap is not much. It is very less. Because of that, they will what? They will form the actinoids will show variable oxidation state. Okay. So these are some of the important questions from your F block elements. Okay. Okay, so these were the important questions. So I have tried to cover all the important questions. Any doubts up to here? Yes, so I've completed the chapter D and F block elements. Okay, and also I've covered some of the important questions. So from this, you might have come to know that what type of questions are asked. Okay, so anything you want to ask me, you can ask now. So if you have any doubts, you can ask me now. Okay, so this completes your D and F block elements. So from tomorrow, we are going to start with the next chapter, that is electrochemistry. Okay, we are going to start with the next chapter, electrochemistry. Yes, any doubts? Fine. So I hope you have understood. So we have completed three chapters. We have completed solution. Okay, then we have completed haloalkanes, haloarenes, and D and F block element. Okay. So I hope you are studying, okay, simultaneously. So whatever the things are told, important questions are told, please study from day one, okay, or else at the end it will be very difficult. So I hope whatever things have been told, you are studying, okay, accordingly, right? Okay. So anything you want to ask me? Okay, fine. Okay then. So I'll end the class here. Yes. So tomorrow we'll start with the new chapter. Thank you.